So we would like to do number 15 in chapter 4, which says we should write as ax equals b some system here. How'd you do the problems before this and then get confused on this one?
Because not all of the equations on these have the same variable, so it's like, wow.
Oh, it's the missing y's. Right here, right?
Yeah.
Okay, so how many y's are there then? Okay, so there's 2 x's and 3 z's is 17, right?
Okay.
How many y's are involved in that?
None in that one. Yeah. Okay.
Right?
Yeah.
We're adding 0 y's. So here, what am I missing? This guy, 3x minus 2y is 10. What's that missing? Yeah, it's missing z's, so really I could think about plus 0z there. And this guy I could really even just write plus 0x, right?
Mm-hmm.
Okay, so I think that should do it. So then if I'm trying to write this out as ax plus b, let's see. So I'm going to make a matrix A. What's that going to be? How did you make the matrix A and the other ones?
I did this like 4 days ago. I can't remember.
Okay, so.
Sorry, I forgot the hand rule, my bad. 2, 0, 3, 17, I think would be the first one. With that bar.
2, 0, 3. So if you were going to write this as an augmented matrix. So I'm going to write that off to the side. So if we were going to write an augmented matrix, then I would write 2, 0, 3 augmented by 17. They asked me to write as ax is b, so I'm going to write this way. And where's the 17 go in this business?
The top on the right of the equal sign.
Yeah. That's the output, right? Okay, what did I multiply 203 by to get 17?
X, Y, and Z.
Perfect. X, Y, and Z. Okay, what's your second row read then?
X negative 2, 0.
3, negative 2,
3,
Okay,
negative
yeah.
2, 0. Good. And then your middle term on the output should be 10. And then this bottom guy reads as what in the A matrix? 0, 5, 2. Perfect. And your output from that equation is 11. And if I was, so this is done with the A, X is B thing. Okay, see that? Where A is a 3 by 3 matrix, right? X is a 3 by 1 factor, right? So I'm going to call that a 3 vector for most of the time. What's the output?
3 vector.
Yeah, also a 3 vector. Okay, so this matrix A, right, is a function from 3 vectors to 3 vectors. Okay, see that? And here, I know what the output is, but I don't know what the input is. So I might try to solve this system. See that? That would be kind of the natural setup that I've got here. It's like a, hey, what are x, y, and z if you get this? Another way to think that is to do this augmented thing. So if I augment, what's the difference? Like, how do I fill in the rest of this augment? What goes on this side? I already wrote the first line, 2, 0, 3.
It's the exact same as the other one.
Yeah, it's
Everything A on the left-hand side and everything B on the right-hand side.
perfect. So really it's A and B, right? So why would you do one or the other?
One's faster than right.
Yeah, this one's faster to write. I'm going to do the exact same thing to solve them. This one's faster to write. So when I actually want to solve one of these, this is what I'm going to do. But what I'm thinking when I write down the augmented matrix is really this thing.
Where do you count for the x, y, and the z on the augmented one?
Good. At the end. It'll be weird. We have to do one thing first, but I haven't taught you to do that yet. So let's We'll do that at the end. Oh, let me give you a little preview. So, you're going to do some magic. It's not really magic. We just haven't learned it. It'll only take a second. But there is some magic that'll be involved here. There's a good reason for the magic, I promise. In the end, you will get something that looks like 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you'll have like number 1, number 2, and number 3. Is all cool with that?
Yay, magic.
Yeah. So this will be awesome, I promise. It's great. It's going to be the best. It's huge. This thing means, if I think back to equation land, right? This first row here, that guy inspires in my head the thought x equals number 1. You guys see that? That's really this process, just run the other way, right? You go from the augmented thing, back to this, back to the equation represented. And of course you get x is whatever number 1 is. What's the second line read?
Y is number 2.
Y is number 2, and z is number 3, right? So they're there. I just don't want to write the x, y, and z every single step of the way because there's going to be a lot of steps. Cool? That's really all this thing is. It's a space-saving technique. When we do this in a computer, it's even faster. And the computer won't output any of this. It'll go from, well, from that first step to the last step without showing us anything. And then I just have to read off the answer. Cool? All right. Maybe we should learn how to do magic soon.